All right, Algebra crew, we are doing the next section. All right, section 11.2, multiplying and dividing rational expressions. I'm just going to go ahead and do the first 6 problems here. All right, on page 673. The more of these you do, the more comfortable you'll get. All right, so problem number 1, we have 2 over 5t times 3 over t to the 5th. Now, remember, with multiplication, we're always multiplying straight across. So we go 2 times 3, which is 6. And then 5t times t to the 5th is 5t to the 6th. Remember, you add exponents there. All right? And then you always have to check and just make sure, can I reduce this anymore? Can I simplify this anymore? No, I can't. So that would be my final answer. Okay? All right, let's look at number 2. Number 2, we got 2x plus 5 all over 4x minus 12. And we're multiplying this by x squared minus 8x plus 15. I'm going to rewrite this, all right, and I'm going to factor this, all right? So I'm going to rewrite this as 2x plus 5. Now, can I factor anything out of this bottom part? Yes, I can. I can take a 4 out, which will leave us with x minus 3. Okay? And then can I factor this quadratic? Well, probably. So remember, get our parentheses. X. Multiples of that'll give us a positive 15, but will give us a negative 8. Well, negative 3, negative 5. All right. Now, what we can see here is our x minus 3's will cancel. So typically that will happen. You'll have something cancel. So our final answer here, all right, in the numerator we have 2x plus 5 and then keep that in parentheses, times x minus 5. And then in the denominator, we just have a 4. All right? And you don't need to multiply that out. Just leave it alone. That would be your final answer. All right, so let's move on to the next one. Let's do number 3. Get our gold out. So now we have division. We have k squared plus k. Well, right away I know that I can factor that. All over 5k. And it says divided by 1 over 15k squared. Whenever you have division, you just change it to multiplication. Do you remember keep, change, flip? So you will keep this. You will change this. And you will flip this. So my new problem becomes k squared plus k all over 5k, because it's keep, you change this to multiplication, and you flip this, 15k squared all over 1. All right, now let's do our factoring. So I'm going to pull a k out of the first one, so we now have k plus 1 all over 5k. And then this is 15k squared all over 1. All right, so These k's will cancel, and this 5 will cancel with the 15, and I'm left with a 3 there. So what do I have? In the numerator, I have 3k squared times k plus 1 all over 1. And you don't have to write the 1 in the denominator. You can just say 3k squared times k plus 1. So that's your final answer. All right, let's move on to number 4. Number 4, it's another division problem. So we have 8x squared minus 12x all over x plus 7 divided by 4x squared minus 9. Once again, keep, change, flip. Right? Keep, change, flip. So the 8x squared minus 12x will stay over x plus 7. Change that to multiplication. Now this is in the numerator, so I now want it in the denominator. 4x squared minus 9. You can see where this is going. That's one of those special cases, the factoring special cases. All right, the difference of two squares. So I'll show you how to factor that. It's very easy. I mean, I've already shown you before, but you might have forgotten. All right, so let's factor. What can I take out of this? Well, I can take a 4x, and I'm left with 2x minus 3. And then in the denominator, I just have x plus 7. And then, remember our special case here, difference of two squares. So this is going to be 2x minus 3, 2x plus 3. And if you do the FOIL on that, you'll get this. All right? So let's start our canceling. What can we cancel? Well, the 2x minus 3 cancels with that 2x minus 3. And I think that's about it. All right? So I think our final answer multiplies straight across. So 4x times 1 is 4x. X plus 7 times 2x plus 3, well, that just stays inside parentheses. And you don't need to multiply that out. That's our final answer. All right there. All right, let's move on to the next one. Number 5. Number 5, it gets kind of weird looking. We have a squared plus 2a minus 8 over 3a. And then you can see there's like a longer division line. A plus 4 over a minus 2. This is just a complex division, all right? And it's like a complex fraction. You can rewrite this to make it look like this, the blue one or the gold one. So let's just do that, all right? Because that's what we're comfortable with. So we have a squared plus 2a minus 8 all over 3a divided by a plus 4 all over a minus 2. And then when we get here, this is a keep, change, flip problem. So I'm going to rewrite this as a squared plus 2a minus 8 all over 3a. So that's keep, change, and then flip. Okay? So, time to factor. So I got an A and an A. Multiples that'll give you a -8, but it'll give you a +2 would be +4 minus 2 all over 3A. You can't do anything with that. And then times A minus 2 all over A plus 4. Well, the A plus 4's cancel. So I'm left with, my final answer is A minus 2 squared, because we have two of them. A minus 2 times A minus 2 all over 3A. There's my answer. All right, last problem. It is another complex fraction problem. All right, number 6. And we have x squared plus 6x. And you can see you got, like, that's written bigger, and you got the longer division line, and then you have x plus 6 over x. All right, so this can be rewritten, all right, as x squared plus 6x all over 1, okay? And then divided by x plus 6 over x. Once again, keep, change, flip. So I'm going to write it down here. We keep this, x squared plus 6x all over 1 multiplied by x all over x plus 6. Let's factor whatever we can. So we have x. We can factor that out of that numerator. Well, the x plus 6's are going to cancel, so what are we left with? X times x is x squared all over 1, or you can just write it as x squared. There's your answer. All right, so hopefully this helped, and hopefully you'll do good on the quiz. Stay healthy.